Okay, let's go on to the next question. Question 5. Okay, so before t equals 0, S1 was closed, and S2 was open, and t equals 0, both switches are flipped. All right, so let's look at this. So at t equals to 0 minus, so this is the circuit that we get at t equals to 0 minus. So we have a 30 volt, 20 ohm, 20 ohm, S1. So since S2 is open, correct? Okay, S2 is open at before t goes to 0. So we just focus on this left hand side of the circuit. All right, so we know that at this point of time, the inductor is short circuit. Okay, the inductor is short circuit. So the equivalent circuit that we get here is 30 volt, 20 ohm, 20 ohm, and 20 ohm here. All right, so this 20 parallel 20, okay, 20 parallel with 20 will give me 10. So the total current here, okay, so so after a while you get used to all the numbers, you will know some shortcuts, correct? So when the two resistors are the same in parallel means you just divide by 2. Okay, so 20 plus 10 will be 30. So the total current will be 20 plus 10, which equals to 1 ampere. Okay, so the current that is flowing through, okay, initially, okay, at t equals to 0 minus is 1 ampere. All right. So that is the current that is coming out of the source, and this 1 ampere is going to split, correct, into both these resistors which are equal. That means 0.5 ampere here and 0.5 ampere here. All right. So when I flip the switch, okay, so before I flip the switches, this is the situation, correct? The inductor is short circuit. Okay, 1 ampere is flowing through, and the 1 ampere splits into 0.5 and 0.5. All right. Now, when I flip the switch, okay, when I flip the switch, what happened? Okay, so it's the right hand side of the circuit here, okay, which is 1 milliampere parallel with 50 and 50. Okay, so when I flip the switch, okay, so let's draw the circuit. So what I get is this. So I get an inductor parallel with two resistors, 50 and 50. Okay, and what we know is at that instance of time, okay, that means at t equals to 0 plus, we already have 0.5 ampere flowing here. Okay, so at t equals 0 minus 0.5 ampere is flowing, okay, in the branch over here in this direction. Okay, and at t equals to 0 plus, the current through the inductor cannot change instantaneously. So the same 0.5 ampere is flowing in the inductor in that direction. That means from top to bottom. Okay, and this current, all right, we know it will come here and then it will split. It will split and then it will go. All right, so with this, we can say that the expression for the current, okay, through the inductor will be I0 e to the minus t by tau plus I infinity 1 minus e to the minus t by tau. All right, and since this circuit has no source inside, all right, which means that whatever current is flowing through the inductor will eventually discharge through the 250 ohm resistors. All right, so eventually the final infinity current will be 0. Okay, so the expression for IT would be 0.5 e to the minus t by tau, where tau is L by R. Okay, and what is L? L is your 1 milli. and R is 50 parallel to 50, correct? Because it is discharging through these two resistors in parallel, so it is 25. Okay, which should be equals to 40 microseconds.